Hey, what's up, guys? I'm here with my boy Allan, and we're about to do an intro into Crux. I'm not actually too sure what it is at the moment, but Allan's going to go over it, and I think it's going to be pretty cool. So let's get into it. Uncool again.
I got a surprise. I'm also not really sure what it is, so
We'll learn together.
yeah. We're going to start from a blank project, and we'll use deps.edn. I guess it's more lightweight. I don't really know. I just do what Rich Hickey tells me. Okay, so I'm going to make a new directory. There we go. We're going to cd into it, and I'm just going to make the file called deps.edn. And then we'll switch to Emacs. Okay, so we'll just open deps. We need some actual deps, first of all. And that will be Crux, because that's what it's about. There we go. So let's grab Crux dependency. Okay, so I think that is pretty much all we need.
Cool. That was an awesome video. Thanks, dude.
I hope you learned something. You would generally add a path, but I think if I was to start the REPL now and then start writing code in a buffer, I could just execute that, and I could play at the REPL. But let's add a path or some paths.
And these are paths to Clojure source code.
Yeah. I think what we would do, and then we would want to actually create that file.
Cool.
So let's start the REPL. Waiting.
There we go.
Okay, so it started.
Well, I think maybe before we start, do you want to give a brief 15 to 20 minute intro on what Crux is about, or what it's for?
Yeah, okay, so Crux is a database. I guess one of the main selling points is that everything in Crux is stored with a time. So if you have a document in Crux, it's got a transaction time and a valid time. Transaction time is when it was transacted into the database, so written to the database. Then the valid time is more of a domain level time, which tells you when that document is valid. So at one point in time, that information is a fact. Then if you, in the future, update that same document, the old document won't be deleted. You will have a new document with a new time, a new valid time. So if there are changes in that document, you can say, give me the first one or give me the second one, and the time tells you when that change was made, at what point in time that change became a fact.
That's like a time machine for your app.
It is, yeah. So it's storing all the versions of your documents all the time, and it does it all automatically. You may not cover it in the video, but if you query a document and you have its ID, you can ask Crux to give you all of the versions of that document going back in time.
Wow, okay.
You can also just use Crux without using any of that stuff. You don't have to care about it. It just happens in the background, and you can use it or not use it, which is nice. You can also do graph queries, which is very cool. I do love graph queries. We'll probably go into those a little bit when you're looking at the queries. And then I think the architecture is very interesting as well. One thing I find helpful is to think of Crux more like a query interface than a database per se, because the way I've been using Crux is I use Crux embedded in my Clojure application. So that would be the Crux node, and that is inside my Clojure application. And then you configure the Crux node to talk to separate applications that store your transaction log and your document store. The Crux itself, the node embedded in your application, uses Crux Db or Allan Db which are key value stores, to store its indexes. Transaction log can be Kafka, can be anything that uses JDBC, so SQLite, MySQL, your relational databases. And then the document store can be the same thing. You can use, say, MySQL as your transaction log and a document store. Crux will sit in your application. That's why I like to think of it as a query engine more than a standalone database, because you can still use these relational databases you already have access to. You don't need to spin up whole new infrastructure.
Yeah.
Which is quite nice.
That's crazy, yeah.
Personal projects of mine, I'm not going to set up a production Kafka cluster.
Plan for the future, dude.
I mean, I might, but I probably won't. So JDBC is very nice for that. So I can start with SQLite. You can then move to, say, a cloud-hosted or cloud-managed MySQL or Postgres, and then maybe in the future I can move to Kafka. If you think this looks familiar, Datomic uses similar principles to this. It's the kind of database broken up into smaller pieces. So we got the dependency. This is all we really need to get started. So let's just grab the import. Okay, let's try to do it properly. There we go. Okay, so now we want to start our node. This is the embedded node. You can use Crux standalone. I haven't used it like that personally, but I know you can. So when you start the node, this start node function will return the node. So we want to assign it to something. We want to keep hold of it.
Okay.
So there we go. Now we've got our Crux node running. Now we can put our data in, transact our data in.
Cool.
So there's some stuff about transactions here. Here we go. Let me grab this. We'll just modify it. Get rid of this. We won't go into what these times mean right now.
So okay, so now we're like submitting a transaction.
Yeah.
Okay.
Here we'll put the map. This will be the document we actually want to transact into the node.
Okay, so you're putting this document inside of the database.
Yeah. Right now the document is empty. I'm just gonna quickly grab some documents I've made ahead of time.
In your personal time.
You know, like on those cooking shows when it's like they put something in the oven.
Yeah.
Just grab this like cooked thing out 2 seconds later. Okay, so we got some cars. So let's add a third car. So this ID key here, you must have that in all of your documents. Crux uses that internally to know which key is the ID of your document. I think the reason they do that is because Crux is schemaless. You don't define what your documents look like ahead of time. I think because you don't do that, you have to explicitly use this key to say which key the ID is.
Okay. Does this have to be a key or can it be a string or an integer or something?
It can actually be anything.
Okay.
Good old Clojure style. That could be your database key. Your database key could be a map.
Okay.
We won't do that. So this will just be car3. So let me make a make. You tell me what make.
Well,
what is your favorite car make?
Everyone knows I'm quite fond of Fiats. So
Fiats.
Yeah, Fiats.
Okay. There we go. Just like that. So we need our ID. We'll just use a keyword. I mean, in your actual program, you probably wouldn't use a keyword.
Can it like auto generate the ID, or do you have to explicitly make the ID yourself?
I think you have to make it yourself. So what I normally do is just use a UUID.
Okay.
I just use Java util to generate a random UUID, and that's my ID. So there we go, Fiat, and the country is Italy, I think.
Yeah. So
we got our Fiat make, and then we.
So I see that you're referring to the ID of, well, there you put in the year as 10, but in the other examples you're referring to the key of the makes.
Yeah. So the ID of the make entity in Crux, it's a document database, but we normally call these documents entities. So yeah, we're putting the ID as a value of the key, and then that will. Later on, when you're doing like a join or a graph query, you can pull in that other entity at the value at make, which is quite nice. Cool. So what am I missing? Model. Well, what model do we have?
500.
A 500. Okay. And the variant is
1.2.
Nice. Okay. Let's just put this in a comment because I don't want to execute this.
So if you put, I see you have a function there, def things, which maps over the list of stuff to put inside of the database and then puts it there. If you ran that twice, the IDs being the same, would that create duplicate data or would that update the data?
It would update it. If any of the data had changed, you will have 2 versions of that document. That actually reminds me of one of the things that you have to do in Crux, which is kind of annoying. You always have to transact in full documents. You can't transact in a partial document.
If we wanted to update car 3 and just the year to 2011 and just pass in car 3 2011, the rest of the stuff would get removed.
It will be removed, yeah. So you'll have the old version, which has all of the keys. You'll have the new version, which only has the year. Okay, so we got our things here. So let's just have a look at them. It's a list of all of our entities that we want to transact into the database. Each entity is wrapped in a vector, and the first thing in the vector is this crux tx keyword with put. So that's just telling it to put it into the database.
Basically, those are the commands you want to run.
So you get like, it's not only put, you get different ones. Like there's a whole bunch of different things you can do, but we're only going to use put, I think.
Cool.
Let's just get rid of that and we'll replace this with things. So there we go. So now this should all go into the database. This is now returning the transaction. So transaction ID 0 and the transaction time is shown.
If you ran this again, would the transaction ID just be 1 and the date updated?
Well, yeah.
Okay, cool.
Go. Yeah. So now I imagine we've got 2 versions of each one of these documents.
Yeah.
Now we can query them. So it's going to take me forever to try and figure out exactly what the API is. So let's just go back to our friendly documentation.
I see this as a Java. Was this a Java library first, or was it
My guess is it's Clojure first.
Java more popular?
Well, they're making it so that you can use it from Java. So I'm just going to get rid of a bunch of stuff here. Most of it.
You just needed the Crux Q and the Crux Db node.
pretty much. Okay, so what do we want to query? I guess vehicles of a certain make.
Yeah, let's. I suppose we can query all BMWs. Is there a BMW?
So,
yeah, there's a BMW.
Yeah, it's BMW. Maybe, yeah. Okay, let's start with that. Let's look for the make. Now I'm saying
Query didn't match expected structure.
it's fine.
Oh, okay. It needs to be within a vector.
Yeah, I always make this mistake, like all the time. We're now getting a vector. Well, we got a set. Inside that set is a vector, and then we got our BMW ID, which seems kind of useless, but it's a good first step.
So you're creating entities where the ID of the entity is equal to BMW.
Any ID is equal to BMW. So rather, any entity with the ID attribute that is equal to BMW. And then we create this logic variable called make. And then the value of that attribute, in this case it's ID, will be assigned to make. So that's cool. Now we can get the car. We can do a join and we can get our car. So the car, we know that the make key in the car entity references the make entity. So now we're saying find any entity that has the attribute make with the value.
So it's actually any car entity that has the attribute make, because the keyword is car make.
This is one of the interesting things about Crux, is I can have several entities that can have this car/make attribute. It doesn't have to be in one document or one type of document. And then this would return all of those different documents.
Okay.
Okay, so let's change this to car and see what we get. Okay, we're getting car 1. So we know what that is because we can scroll up and we can see it's this BMW, but that's not very useful. So we want to get more than just the ID. So we'll use what is called the pull syntax. We'll say from car, pull all of the keys of that document. There we go. Now we get our full car. So here we don't have to pull everything. We can say we just want the year and the variant. We can just say, we can just tell it what keys we're interested in, and then we'll get them.
Okay, rad. And the question mark before the logic variable?
So that's a convention. You don't have to do that. You can just omit that and it'll work fine. I like to do that because it distinguishes any other variable you might have from the logic variables. So other variables you might have would be arguments that you pass in.
Okay.
You know, so you wrap this query in another function, you pass in a year. Now inside the query, year is going to be assigned to probably the variable called year. So the question mark helps tell you which is which.
What's query, what's value.
Yeah, what's a passed-in value and what is a logic variable. So let's change this back to all of the keys, and then we'll add in the make key here. So we've got BMW back. Now let's say we want to expand this make to be the make document, or the make entity rather, the full entity. So we can just wrap this in a map. Then we'll say, give us the full entity. So you can think of this as a little graph query. You can think of make as the edge, and then it's attaching the car node to the make node via the make attribute. So if we run this now, you can see now we've got our full entity as part of the car entity, which is really cool.
So it knows that the make entity is attached to the car make via the car make key.
Well, I think what you're wondering is what would happen if I did this for a different key.
Yeah.
That did not have an ID added. I don't know. Let's see. What if we do it with year? I imagine something's going to break. I just have that feeling. So I guess it's just trying to join and it's just not working. You know, it is schemaless, so you're not telling it beforehand what is going to be a reference to another entity. Another thing that is very cool about Crux, you can put in most types. As an example, let's add, I don't know, maybe a thing. It was called thing1, and then a time. I just need to make a Java time instant. Now, okay, so let's see what we get. Actually, let me just execute the map. Now we will transact that.
So this just basically has the ability to serialize anything.
It seems like it, yeah. There may be limits to it, but you know. So we'll put our thing here.
Doesn't that have to be a vector?
You are right. Okay. Got our next transaction. So this is you know, I kind of hyped this too much because now you just know what's going to happen.
It takes a bit of time though, like getting it in there.
It's like, let's just write this whole thing and you know. So we want like just the thing.
So we just
we want something with the attribute thing time. So we'll just say give us an entity that has that attribute.
Okay.
And we're gonna call it thing, and we're gonna use the pull. Let's not use the pull syntax. Let's just get the time. We've got the ID of the entity that has that attribute. Now we want the actual time attribute.
Okay, so now you can either use the pull function or you can use it like this, where
so no, I forgot to update. So yeah, you can pull out attributes in the find. You don't have to use pull. I think that's probably useful if you just want values more than maps. So there we go.
Wow.
So it's already the instant, which is pretty cool. So if you use like UUIDs for your IDs, and you transact in the UUID, when you get it back, it's a UUID.
So you're trying to say that that's not the string value of the Java instant.
No.
That's the constructed value. That's the object. That's really cool.
It would be interesting to know what they actually do under the hood. How they store it. I mean, do they serialize it? I don't know. It'd be interesting to know. What else can we do? So I know you can use functions in these queries as well. You can use Clojure functions. You can write your own functions and use them. I'm just going to copy this. I'm just going to create an empty vector here because I know I'm going to get to it again. Okay, so what do we want to find?
Can we query like all vehicles that are between the year 2013 and 2015?
So we would get
Those two
BMW.
yeah, car 1 and car 2 back, but not car 3.
So we want a variable that holds a year. So there we go. We've got our 3 cars. So I've named this wrong. This should not be year. It should be car. Can we just get the value of the year immediately? Change this back to year. Okay, there's our years. So now we can actually change this to an underscore, and we can carry on. So the underscore is just saying I don't care about that entity ID. So now we need between.
So it'll take a year range. So year 1, first year and second year, or beginning and end.
Year 1, year 2. Let's use the greater than. What should we call these? Because these aren't great names, are they?
Before, after, yeah.
Let's just go with that. Before, after, and year. I think we would change this around then.
Before and after are terrible names also. Min and max, that's actually what it should be called.
Okay.
Yeah. We can do this.
So, I'm telling you, this is like greater, less than, and ends and knots. It's hardest stuff in the world. There is nothing harder.
Yeah.
Less than, max, and.
Yeah.
Oh man, this is like greater than, less than, and all in one. and then year must be greater than min.
Yeah.
Okay. Now we will test this because
there's some bugs there.
yeah,
Yes.
seems legit. Okay. So we need to use the in keyword in our query. In allows you to pass in parameters. So the reason you use in is because within in you assign names to your parameters. I'll explain a little bit more in a second. Let's just get it in there. So this query function, you can see after the query map, it takes a set of arguments. Now those arguments are positional. And this in, the vector that is the value of this in key, allows you to name those positional arguments. So if you had 1, 2, 3 here, you would name them here. So 1 between would be 1, and then so on.
Okay.
Just like function arguments. But we don't have 3, we just have 1. And that 1 is our between function. I don't think we would have to pass it in like this if I fully qualified it.
Okay.
With this namespace, which we can try. We'll try both ways. Okay, so I want to call this between function. I want to say the car year should be between min and max, right? So
yeah.
What are we saying? We said
2016 and 2012.
Yeah, so
min is
min, and then 2016, and then the cars year. Yeah, so let's run this and see what we get. Okay, it seems good.
Yeah, okay. But now we're obviously just returning the years, not the full documents.
Now we need our entity ID back. Then let's introduce the full syntax again, and we'll just say all the keys. Actually, let's get a window up. There we go. So
cool.
We've still got our years, because you can see in the find I've got year, and then I've got pull car, so we're getting both.
Cool. That's really crazy. That's quite insane to use your own function in a database without having to match the database syntax.
Just quickly, let's try fully qualify this function. So, okay, so I'm just gonna nuke that and that. So there we go.
Oh, cool. It still works.
It still works, yeah. So the way we did it, where we passed in the function, if you defined a function in a let and there was no easy way to fully qualify it, yeah, you could pass it in that way. If it is a top level function, you can fully qualify it. So, yeah.
Cool. No, this has been really cool. It actually was a lot easier to set up for than I thought it would be for what it was, like for what it is, which is pretty cool.
Setting it up, getting it running is very easy. The thing people may struggle with the most is datalog, which is the name of the query language. If you do struggle with it, just keep it up, because once you get a hang of it, it's pretty easy and it's pretty fun.
Well, I really liked it, and it's something that I think I'll play around with. So, thanks for watching, everybody. Cheers.
Cheers.
Cheers.